Hello, I'm Pierre-François Duc. I'm a grad student in experimental condensed matter at McGill University. Today, I'm going to give you an introduction to an automated measurement project we co-created with Benjamin Schmidt, another grad student from my lab. I will use a simple physical problem as an example to highlight why you might want to use our program as a foundation block to build your own automated experimental setup. If you decide to use LabGui for your own experiment, we will be happy to help you get started using it by holding an introductory workshop at McGill on May 19th from noon till 4 p.m. To learn more, contact us at rtech@physics.mcgill.ca and check out our Facebook. We also have some funds to help cover transportation costs for the participants. As an experimental scientist, one needs to perform measurements. The easiest way is the manual one. Let's see how this works with the following simple example. You are given an unknown resistor and you need to determine its resistance via measurements. You are fortunately aware of Ohm's law, which states that the resistance is the proportionality constant between voltage and current. Therefore, you decide to connect your resistor to a current source and measure the voltage across it. We do a first measurement. We apply a known current and we measure the voltage. Then we report that on a graph. We then repeat the procedure. We apply a known current, we measure the voltage, and we report that on a graph. In order to reduce your error on the measurement, you need to repeat that a lot of time. For the current example and for simplicity, we choose 5 times. And this is the result. And this is the graph. Thankfully, the realization seems to be linear. We can use a linear regression method on the data set to extract the slope, which is equal to the resistance we wanted to determine in the first place. Good job, you succeeded. Now that we are done, let's ask ourselves, is this really a job for a student? No. There are ways to automate that process and do much more. Let's look into that. Today, almost all measurement devices have the possibility to be controlled by a computer. I will show you how you would typically carry the same Ohm's law experiment using the computer software we designed, LabGui. First of all, no need to turn some knobs or look at different instrument screens. You control all of them from your computer and you can perform one measurement with a simple click. This is what the script looked like in LabGui for that particular experiment. Like before, we apply a known current and measure the voltage. We then report that on a graph. You need to do that more than once for better statistics? No problem. You simply add a for loop. Click only once and get all your measurements done. What about fitting the slope to get the resistance? The data are already on your computer. You can run a fit procedure on them with a simple click and get the fit parameters. What about nonlinear fitting? You can fit any function on your data. Select the function you would like to fit, click, and see the result. If Ohm law would have this complicated form, this would be the result. If you want to repeat the same experiment more than once to get better statistics, it is easy. Simply add another for loop. This way, you can already see the fit of the data which are already taken while I query more data, and even change fitting function back and forth if you like to do so. You can also go grab a coffee while your experiment is running. A bonus feature: you can receive an email when your experiment is finished or if something happens, and enjoy the sun outside your lab. Now you can say, but I am already using LabView to perform my measurements. Why should I use LabGui? Let's compare their key features. For both LabGui and LabView, all the instruments speak one language. Once a driver is written or given, the communication with the instrument can be established. This can be done both in LabView and LabGui. So LabGui can do this as well as LabView. Second thing I would like to mention is that LabGui is a programming language and LabView is a graphical programming language. And you actually care about this difference if you are dealing with a complex project. I will first show you an example of code in Python and in LabView. As you can see, LabView doesn't use text-based code but a flowchart. This is powerful to rapidly implement simple programs, but when the program becomes more complex, you get into this. LabView makes the easy thing easier and the hard thing harder. The learning curve of graphical programming language is lower but so is the productivity. One of the advantages of a programming language is much more convenient version control. Moreover, it is cumbersome and slow to use a graphical programming language over SSH or on all computers. Proprietary against open source software. You can access all the code. We don't hide anything from you. If you want to modify some parts of the code to better suit your needs, this is important. Open source doesn't mean that there is no license. We have a license which forbids one to take our code and make profit out of it. Copy is allowed, modification is allowed, profit is not. This brings us to our next point. This software is free of charges, while LabView is costly. And most of the time, we only use a small portion of the feature we pay for in softwares. Another advantage is that you can use any text editor to write your code in Python. Some of them will even allow you to run your code directly from the text editor. With LabView, you can only use the program on a limited number of computers, depending on which license you pick. Speaking of license, I want to underline the fact that LabView backward compatibility is not the best. This is a table of all possible combinations of save in one version, open in the other version. Green means that you would not need to buy a newer version of LabView if you'd like to continue working on a project, while red means that you might have to. As you can see, using LabView might cost you more than you expect, while our package will always be free. Last but not least, the Python community is huge, so new packages develop really fast. Since I started using it, many packages became even better. Also, many scientists use Python to analyze, acquire and plot the data, paper quality data and graphs. At last, here is a little summary of the points of comparison between LabView and LabGui. You can download LabGui and start using it on your own, or drop by our workshop on May 19th and let us help you get started customizing LabGui for your needs. We'll also be happy to answer your question by email.